Welcome students to the class of digital signal processing. Today we will be doing some numerical problems so that we will be getting idea, or not actually idea, the in-depth understanding of how to do the calculation, how to get the ROC for the sequences that have been given to you. So here we will be doing 5 questions, and all the questions are of varied natures, which will help you understand the method of calculation, the variations in calculations, how the limit changes, and how the ROC changes with the change in the signal. Okay, so let's get started. Xn is equals to u of n minus u of n minus 3 is your first question. So let's do it. X of n. Give me a second. Let's take the black ink. X of n is given equal to u of n minus u of n minus 3. Now seeing the sequence, it is a unit step sequence. This is starting from 0. So at 0, it's 1. The value is 1. For 1 also, the value is 1. So this way it will go on, continue. And this one, this is again the unit step sequence, but it starts from 3. So at 3, then 4, these are the values that it will be 1. Now, if you take the Z transform, we know the formula now. So the formula is what? N is equals to minus infinity to infinity, x of n, z to the power minus n. Now, here the x of n is what? The x of n is given to us u of n minus u of n minus 3. The whole thing is kept inside the bracket, and then you have z to the power minus n. Now, see, you can break this into different summations because of the linearity property of Z transform. We will be doing that. So linearity property says that the two signals can be in the two signals, this one u of n and u of n minus 3 can be separately written with their Z transforms being the respective Z transform being the over of Z transform. Okay, means the respective Z transform when written together will be the overall Z transform of the signal. So u of n z to the power minus n minus n is equals to minus infinity to infinity, u of n minus 3, z to the power minus n. Fine. Now you see, the first one, the signal is starting from where? The signal is starting from 0. So we will change the limit. We are going to change the limit. N is equals to 0 to infinity. The value is 1, z to the power minus n, minus, again here the limit will start from 3. Because just now we saw the unit step sequence is starting from 3. Here, because it is shifted n minus 3, how we are getting this part? Let us see this very quickly. If you write over here n minus 3 greater than 0, because unit step sequence exists only for n greater than 0. So inside this part, you have n minus 3 now. So n minus 3 greater than 0, that means n is greater than 3. So from 3 to infinity, the value is 1, z to the power minus n. Now, both are geometric sequence, infinite geometric sequences. So, the sum of this will be a by 1 minus r. The only difference between these two is the first term here is 1 because of z to the power 0. And here the first term is z to the power minus 3. So, the final answer here will be 1 by 1 minus z inverse. And in this case, the final answer is going to be z to the power minus 3 by 1 minus z inverse. Now, how did I write this thing? See, if you are going to expand the first one, that is n is equals to 0 to infinity, z to the power minus n. So what will you get? 1 plus z to the power minus 1. So n is equals to 0 from starting. So when you put 0, it is 1. When you put 1, it is minus 1, then minus 2, and so on. It will go on. If you divide the third term by the second term, z to the power minus 2, by z to the power minus 1, answer will be z to the power minus 1. Any two consecutive terms you can see, if you see the second divided by first, that time also it is going to be z to the power minus 1. Similarly, if you see the other sequence, it is again, that is z to the power minus n only, but from 3 to infinity. So if you see over here, first term is what? Z to the power minus 3, then z to the power minus 4. This way it will go on. So the first term is z to the power minus 3, but the common ratio again is going to be z to the power minus 1. So final answer, what you will be getting is, this is your x of z. If you simplify it, the denominator is same, 1 minus z inverse, and this one is If you try to simplify it more, so you can write the numerator as 1 by 1 minus 1 by z cube, 1 minus 1 by z, and then here you can write it equals z cube minus 1 by z into z by z minus 1. Right, 1 by z is here. Got it? This one is z cube. So now this and this will cancel. This will be z square. And the top one, the z cube minus 1 can be written as the formula of a cube minus b cube. That would be z minus 1, z square plus z plus 1. And again, you have this z square and z minus 1. So these gets cancelled. The final answer for x of z is z square plus z plus 1. Now finding out the ROC, just see the R. Here the R was, for both of them, the R is z to the power minus 1. This is your R, right? This is the R. This is the R. So you know the condition on infinite geometric series, that for infinite geometric series to converge, mod of R should be lesser than 1. What was my mod of R? My mod of R was Z inverse, mod of Z inverse, right? So mod of Z inverse is lesser than 1. This is for both the signals. Same thing was there. So if you write it, it will be 1 by mod of Z lesser than 1. This will give you mod Z greater than 1. Mod Z greater than 1 means there will be a circle which is centered at the origin. The radius of this circle is going to be, this is what mod of Z greater than 1. So what does that mean? Mod of Z minus 0 is greater than 1. So if you write it mod of Z minus 0, if you write it mod of Z minus 0 equals to 1, that time it means that Z is a complex number, but it is signifying a locus of circle, because from a fixed point 0, the distance of the locus is fixed at every direction you take. So this is 1. That is a unity circle with centered at origin, but the region of convergence is outside this. So you are having the region of convergence. What is the region of convergence? The region where the Z transform exists. So this is your first question done. Let's move on to the next one. You can just go back and see it if you have not understood at any point. Or once again, quickly we'll do it. First, you will take u of n minus u of n minus 3 for u of n. It is starting from n equals to 0 and going till infinity. For u of n minus 3, it is starting from 3 and going to infinity. Now, the first term for this one is 1, and for this one, the first term is z to the power minus 3. Both of them have the common ratio z to the power minus 1. Simplifying this, you get the answer of x of z. And for the ROC, you are putting the condition that is mod of R lesser than 1. Here R was mod of Z inverse. This one was your R. So R was given to us as Z inverse. So mod of Z inverse is lesser than 1. Okay, let's move on to the next question now. X of n is equals to 3210. X of n is equal to 3210 and 3, 1 minus 2. 3, 1 minus 2 with the origin at this point. Now see, this is the 0th position, first, second, third position. This is minus 1 position, minus 2 position, minus 3 position. So this is our two-sided sequence. This is a two-sided sequence because there are digits, or you can say there are numbers to the left of 0 and to the right of 0. If only there were numbers to the right of 0, it was a right-sided sequence or right-hand sequence. And if there were numbers only to the left of 0, it was left-handed sequence. Now, again, in this case, how we will be finding the x of z? X of z will be summation n is equals to minus infinity to infinity xn z to the power minus n. But as we saw, it is starting from n is equals to minus 3 and going till 3 x of n z to the power minus n. If we expand this and write, it's x of minus 3 z to the power minus 3, x of minus 2 z to the power minus 2, x of minus 1 z to the power minus 1, plus x of 0 z to the power 0. That is going to be x of 0 plus x of 1 z to the power minus 1 plus x of 2 z to the power minus 2 plus x of 3 z to the power minus 3. You see the sequences? It was starting from 3 to 1 0, right? So x of minus 3 was 3. So this is going to be 3z 3 2 then 1 then 0 then again 3, right? 3 2 1 0 and 3 1 minus 2. So 3 was the value of x of 1. 1 was the value of x of 2. And minus 2 was the value of x of 3. So this way you are getting it 0 3 1 minus 2. Now see how to get the ROC. So this is x of z. Now this is your x of z. What is your ROC? If you put infinity over here, x of z will become infinity. And if you put 0 over here, then x of z will become infinity. So ROC will be entire z plane except entire z plane except z is equals to 0 and z is equals to infinity. Because this is a double-sided sequence, both 0 and infinity is not included. If it was only this side was present, means it was right-sided sequence. In that case, here the power of z is in minus, so z is equals to 0, not in the ROC. And for this side, z to the power, positive power is going, so z is equals to infinity will not be in the ROC. Fine, z is equals to infinity won't be in the ROC. And for the two-side sequence, both of these will be together not included in the ROC for the Z transform. Let's go to the next question. So for us, the next question is 0.5 to the power n and 0.2 to the power n. 0.5 to the power n is existing for minus infinity to 0, and the other one is for n greater than equals to 0. Let's do it. So the question says x of n is equals to 0.5 to the power n for minus infinity less than n less than 0. And the other one is 0.2 to the power n for n greater than equal to 0. Let's once check it once more. Minus infinity to 0 and greater than equals to 0. So for finding out the Z transform, again we will go on by the same process. Summation n is equals to minus infinity to infinity xn z to the power minus n. So here you can see this is n value is divided into two parts. First part is minus infinity to minus 1, where the value of xn is 0.5 to the power n, right? Z to the power minus n. The second part is n is equals to 0 to infinity. Here the value of x of n is 0.2 to the power n, z to the power minus n. Now here you see minus infinity to minus 1. If you want to change it to positive infinity and also change the order, means n is equals to 1 to infinity, right? If you want to write it n is equals to 1 to infinity, you can write it. The only thing is that your sign for the things inside the summation will also change. So this positive n becomes negative n and this negative n becomes positive n. Fine. Now this side what we are going to do is n is equals to 0 to infinity 0.2 z to the power minus 1 whole to the power n. So this is already there in the right format, and the other one we need to just do it. Okay, let's now go ahead. This is what we are calculating. Now x of z, for this case you see, you can write it n is equals to 1 to infinity 0.5 to the power minus 1 z to the power n. And this one will be what? The first term here will be when you will put the value of n equal to 0. So first term will be 1 minus the common ratio is going to be 0.2 z inverse. Why? Just see this part. The first term is 1. The second term, when you put the value 1, 0.2 z inverse. Third term, 0.2 to the power 2 z to the power minus 2. So if you divide this, you are going to get 0.2 to the power z into z to the power minus 1. That is your common ratio. In this case, if you see, the common ratio will be, the first term will be what? Since the value of n is starting from 1, so my first term in this case is going to be 0.5 to the power minus 1 z to the power 1. And this is the same thing which is going to be my common ratio. Why? See, first term is 0.5 inverse z to the power 1. Second term is 0.5 to the power minus 2, z to the power 2. If you divide it, you will get z to the power 1. Here, if you divide it, you will get 0.5 to the power minus 1. So if you write this part, it's going to be 0.5 to the power minus 1 is what? 2 by 1 minus 2z. And this side, if you write it, it is simply 1 by 1 minus 0.2 z inverse. You can simplify it more. I'll leave it at this point and find out the ROC. Simplify it more means you can write the same thing, this one more simply, 0.2 z inverse. That's it. I'm writing it 1 minus 2z plus, if you write this portion 0.2 by z, that will become 1 minus 0.2 by z. That will finally become z by z minus 0.2. Now, if you go for the ROC, just you have to see over here, the 2 in this format itself for the ROC. 0.5, I will do the ROC by a different color. So let's do it with the red color. So here you see 0.5 inverse z should be lesser than 1. And this side, it should be 0.2 z inverse should be lesser than 1. So first let us solve the other one. 0.2 z inverse means 0.2 divided by z. So this z, if it goes this side, it is becoming mod z greater than 0.2. Now this part is actually what? 2z less than 1. So if you can write it mod z lesser than 1 by 2. 1 by 2 is what? 0.5. So if you draw the ROC, it will be 2 circles. One will be of radius 0.5 and the other one will be of radius 0.2. Right? So 0.2 only. 0.2. So this one is 0.2 and this one is 0.5. Let us see once more. Mod z is greater than 0.2 and lesser than 0.5. Greater than 0.2 and lesser than 0.5 means the annular region. So this is your answer. This portion is the ROC or the region of convergence. So this is the ROC, where the Z transform exists. And this is the value or the magnitude of the x of z. Okay, now the next question is x of n is equals to a raised to the power of modulus n, where mod of a is lesser than 1. Okay, let's do this question. X of n equals to a raised to the power of mod n, where mod a is lesser than 1. That means the value of a is from -1 to -1 is less than a is less than 1. Okay, that means this value is ranging from -1 to 1. That means that it's going to decrease. So it is a converging sequence. Okay, finally we need to find out the x of z. So here x of z is what? Again, same thing, n equals to -infinity to infinity. X to the power x of n, a is z to the power minus n. Now this signal again, first let me write this signal properly. Okay, so this one, see over here, it is what? X of n is equals to a to the power positive n and a to the power negative n. Positive n will be from where to where? Where the value of n is greater than 0 and this one is for value of n lesser than 0. So now if I write this part, that is, if I am breaking this summation, then from n is equals to minus infinity to minus 1, that means all the minus terms we are putting together. So for that, it is going to be a to the power minus n, z to the power minus n. And for the other one, that is from n is equals to 0 to infinity, is going to be a to the power n, z to the power minus n. Same as one of the question we did previously, we are going to change the limit over here, n equals to 1 to infinity. If we change the limit over here, the sign of the things inside it is going to change. It will become a to the power n, z to the power n. Now this is n is equals to 0 to infinity. A z to the power minus 1 to the power n. Fine. And this is going to be what? A z to the power n. Right. So let me write it very nicely now. Once again, x of z is going to become 1 is to infinity a z to the power n, and this one will be plus n is equals to 0 to infinity a z inverse to the power n, a z inverse to the power the first term over here is how much? Az, right? So what we are writing is az by 1 minus az. Here the first term is az, here the first term is 1. Because if you put the value of n equals to 0, it's going to come 1. 1 by 1 minus az inverse. This is your x of z. You can again simplify this. And over here you see, it's starting from 1. So the first term is az. Az, a square, z square, a cube, z cube. This way it is going to be. So it is going to be this way. Az, a square, z square, a cube, z cube. If you take the ratio of this or this, you are going to give az as your common ratio. In this case, the first term is a1. The second term is az minus 1. Third term is a squared z to the power minus 2. If you divide this one by this one, you are going to get this as the common ratio. Now, for finding the ROC, mod of az is lesser than 1. Mod of a is lesser than what? 1 by z, right? Because see, or you can do one thing. Instead of taking this z to that side, we will take a to that side. So here it will remain mod z lesser than 1 by mod a. And this one, if you take this one, then it is coming az to the power minus 1 lesser than 1. Again, in this case, mod a is greater than mod z. So there will be two circles again. One circle will be having the radius of 1 by mod a. So let's do the ROC this side. So if you draw the circle for the first one, it is 1 by a. We all know 1 by a is lesser than a. So I have drawn a circle in that manner only. Let's draw the other one. So this one will be a. Fine. Now it has to be lesser than 1 by a and greater than a. Fine. So lesser than 1 by a and greater than a. So what it will be, this a is going to come this side. Okay, so we'll have to change the circle over here. Now here a value is not given. Naturally 1 by something is lesser. That's why I did it. But since the circle value is something different, we will have to take the a and 1 by a differently. So a will be inside and 1 by a will be outside. This one will be a first circle and the bigger circle is 1 by a. Now if you take the ROC, it's going to be this portion. And in case this 1 by a is greater than a, that case the outside of it will become the ROC. For now, the ROC for this is what? Mod of a is lesser than z is lesser than 1 by mod of a. This is your ROC. They will give you like a 1 by a or whatever it is. They will give you the value that whether it is greater or small. If it is not given, whatever is coming, write it in that way. Now the last question for today is x of n is equals to half to the power n u of minus n. This is the question, but I think you can do it now because we have done several sequences which are going from minus infinity, right? So the question is x of n is equals to half to the power n u of minus n. So this signal is existing for n lesser than 0. So if I find the xz, which is n is equals to minus infinity to infinity x of n. Now if you write this again, then it's going to be how much? It's going to start from n is equals to minus infinity and end at minus 1. So that is it, half to the power n. Why this happened? Because of 0 u to the power minus n. What is it, this u to the power minus n? This is a unit step sequence only on the left side of 0. So left side of 0 means it's starting from minus 1 and going till minus infinity. Now if I want to change the limits over here, n equals to 1 to infinity, the sign over here is going to change. Instead of writing half, I will write it 0.5 to the power minus n z to the power positive n. Again, clubbing it together, if you write z to the power whole n. Again, it is from where to where? N is equals to 1 to infinity. N is equals to 1 to infinity. So now 1 by 0.5 is what? 2z. 2, right? So 2z to the power n. From n is equals to 1 to infinity. If you put the value of n is equal to 1, your first term is going to be 2z. And the common ratio is going to be how much? See, the first term is 2z. Second term is what? 2 square z square. Divide it with this. What you will get is 2z. So 1 minus 2z. This is your z transform. And how will you get the ROC? Just take this 0.5 z in 0.5 inverse z, or say 2z lesser than mod of 2z lesser than 1. So that will give you mod of z lesser than half. So that is what the ROC will be inside a unit circle of radius. How much? 0.5. ROC will be inside the unit circle of radius 0.5. I hope you have understood all the questions. You can pause it and solve on your own, then recheck, or wherever you find it there is some problem, you can just pause it and do it redo it. These questions will be extremely useful for your MCOUT exams. Thank you. We'll meet in the next class.